and they exhibit highest bond energies. That means their strength is highest amongst all kinds of bonds. Further, we are going to discuss about intermolecular forces of attraction. These forces, either attraction or repulsion, they act between neighboring particles, that is atoms, molecules or ions. These are very weak compared to intramolecular forces such as covalent or ionic bonds. They develop between atoms and molecules. Intermolecular forces, they had been given name van der Waals forces after the name of scientist van der Waal. These include Keesom forces, dipole forces, London forces or dispersion forces, and hydrogen bonding. Before understanding these, we must understand how permanent dipole is developed. So when two atoms in a molecule have substantially different electronegativity, one atom attracts electrons more than another, becoming more negative, while other atom becomes more positive. For example, peptide bonds. Now there are some atoms which are electronegative in nature, example oxygen, fluorine or nitrogen. So when these molecules are present in the molecular structure, they do attract the electron pair towards themselves, and due to this they acquire partial negative charge. But this brings about a positive charge at another end of the molecule. So distribution of charge develops in the molecule, which is nothing but permanent dipole development. This is responsible for the interaction between two permanent dipoles. That means one partially negative end of dipole will attract partially positive end of another molecule. So these interaction coming under dipole-dipole interactions. Permanent dipole, they can induce temporary dipole in otherwise neutral molecule. So this is referred as a induced dipole, where there is temporary development of distribution of charge. Now we will see different van der Waals forces of attraction. In that, first is ion dipole, where an ion is interacting with one pole of dipole. This is quite strongest bond as ion is involved. The bond energy lies in the range of 40 to 600 kilojoules. Example is sodium cation is developing interaction with oxygen of water. Then hydrogen bonding. Students, we are going to study hydrogen bonding in detail in later slides. Next is dipole-dipole interaction, where one permanent dipole interacts with another permanent dipole. Here the bond energy is 5 to 25 kilojoules. An example, Cl chlorine develops interaction with iodine. Ion induced dipole, where ion is interacting with a induced dipole, means where the dipole is induced temporarily. So this is having very less bond energy, 3 to 15 only. Example is Fe2 plus and oxygen atom. Next is dipole. Sometimes when comes in close proximity with another neutral molecule, it can develop a temporary dipole. So this is interaction between a dipole and induced dipole. The bond energy is very less. These are still weaker, 2 to 10 kilojoules. Example, chlorine of HCl interacts with chlorine of chlorine gas. And last, dispersion forces, or they are also referred as London forces, where both molecules are neutral, but when they come close together, they can develop polarity in one another. That is induced dipole type of interactions, and they have lowest bond energies in the range of 0.05 to 40 kilojoules. Example is interaction between the fluorine and fluorine atom in fluorine gas. So all these are coming under the broad category of van der Waals weak interaction forces. So the characteristics are, these are weaker forces than covalent bonds. The solids which are held together by van der Waals forces, they possess low melting points. Dipole-dipole interactions, they are referred as Keesom forces. These are weak interactions observed in large molecule with force of 1 to 7 kilocalories per mole and inversely proportional to the distance between molecules. Then dipole-induced dipole forces, they are named as dipole forces. These are permanent dipoles. They cause distortion of electric charge and shift the electrostatic charge to neighboring polar and non-polar molecules and thus temporarily induced polarizability. These are attractive forces between the permanent dipole and ion. They are known as dipole-induced dipole or ion-induced dipole. And the energy required for this interaction is 1 to 3 kilocalories per mole. Finally, London forces or dispersion forces. These forces are weakest intermolecular force. The London dispersion force is temporary attractive force which results when the electrons in two adjacent atoms occupy positions that make the atoms, they form temporary dipoles. Because of constant motion of electrons, an atom or molecule can develop a temporary or instantaneous dipole when its electrons are distributed unsymmetrically about the nucleus. So these are nothing but induced dipole kind of interactions. Very important in this category is hydrogen bonding. The hydrogen bond is an attractive force between partially positive charge hydrogen and partially negative charge atom, may it be oxygen, nitrogen or fluorine. In this figure you can see that two water molecules are there and oxygen being electronegative develops a partially negative charge, because of which these hydrogen develops partially positive charge and the positive hydrogen interacts with negative oxygen of another water molecule. So this is weak bond and the strength of hydrogen bond lies between 5 to 10 kilocalories per mole. This is very less as compared to strength of covalent bond. The shared electron pair between oxygen and hydrogen, it's pulled towards the electronegative oxygen. So there happens unequal distribution of electron pair, leads to formation of two partial dipoles, and this is reason for hydrogen bonding. Hydrogen bonding is also of two types. We can classify this as intermolecular hydrogen bonding and intramolecular hydrogen bonding. The intermolecular is hydrogen bonding when it occurs between atoms of different molecules. It is referred as intermolecular. Here you can see example where this carbonyl oxygen interacts with the hydrogen of water molecule. So this is intermolecular, but it can develop within a single molecule. Example is salicylic acid, where you can see this carbonyl oxygen of carboxylic acid group. It interacts with the hydrogen of alcohol group in the same molecule of salicylic acid. So this is example for intramolecular hydrogen bonding. Hydrogen bonding plays a crucial role in phase transition of water. So when solid ice, when energy is supplied, it gets melted into water, and it is said that 1/6 of hydrogen bonds break when ice melts to water. If further energy is supplied, then water completely loses all hydrogen bonds and it becomes vapor. Hydrogen bond gives water molecule a structure which is a regular tetrahedron, and the oxygen is forming hydrogen bonds with neighboring hydrogen atom of water molecule. Then we will study effects of hydrogen bonding on certain important properties, that is on boiling point. Because of hydrogen bonding in alcohol, the boiling point rises. Extra energy is needed to break these hydrogen bonds before it boils. So as there are no hydrogen bonds, alkanes and ethers, they have low boiling points. You can see an example. As compared to propane and ether, ethanol is exhibiting higher boiling point. It also has effect on solubility. A polar molecule like alcohol, it can enter into two water molecules to form hydrogen bonds. While a non-polar substance like alkane, it will exhibit low solubility because it cannot enter easily in the polar structure of water molecule. So you can see this alcohol, it can get easily accommodated in the water molecule structure. So students, this is all about intermolecular forces of attraction. Now we will see how the transition of state occurs. Now first we are going to have a look at solid state. Here the molecules that make up solids are arranged in regular repeating patterns. They are held firmly in place but can vibrate within a limited area about some fixed position. So they are having a definite shape and volume and firm structure, whereas the liquid, the molecules that make up liquid, they flow easily around one another, but the molecules, they are not allowed to leave the phase boundary, and so they are kept away from flying by attractive forces between them. The liquids assume the shape of their containers. Then gases, these molecules, they make up the gas. They can fly in all directions, they can move randomly, and they are very far apart, so the attractive forces between them are insignificant. And the fourth state which we studied is plasma. At very high temperature of stars, the atoms, they lose their electrons, and the mixture of electrons and nuclei that results is nothing but the fourth state, that is plasma. Now here this diagram depicts the transition of states. Solid, where you have highest degree of intermolecular forces, if it is supplied with certain energy like increasing temperature, then if it gets transformed into a liquid, the process is referred as melting. And if it is cooled, that means the energy is withdrawn, then liquid is said to be undergone freezing to give you the solid. When this liquid is heated and converted into a gaseous form or vapor form, it is referred as evaporation. When the vapors, they are cooled down to give you liquid, it is referred as condensation. Similarly, sometimes the vapor pressure of some solids are so less, like in case of camphor iodine, that without transforming into liquid state, the solids can easily converted into gaseous state. This is referred as sublimation, and the reversal of this process, when gas is condensed to a solid, it is referred as deposition. Now between these transitions there exist some mesophases. Mesophases, meso word is a Greek word which means middle. So example is supercritical fluid. The supercritical fluid is a middle phase between gas and a liquid. So it has properties of gas as well as liquid. Similarly, a liquid crystalline state is also mesophase, which is a phase between liquid and solid. Middle phase between liquid and solid is liquid crystalline phase. So this is all about transition of states. So herewith we are ending this session. I hope you understood the contents we covered today. Thanks for listening patiently. Bye students, happy learning.